Welcome to this first edition of Basic Mathematics, where we will learn something about real numbers. And I am hopeful that this video will be helpful to all those, not only students, but also those preparing for competitive exams and those who want to revise their basic facts about mathematics of 9th or 10th standard. It will greatly help them to grasp the very root idea about real numbers. So, what are real numbers actually? Real numbers are all those numbers which we generally use in our daily calculations and day to day life. And as you are all familiar with numbers such as 1, 2, 3, 4, 5, 6, so on and so forth. So, with this, I would like to classify this real number into first one, natural number, second one, whole number, next one, integers, and in integers we have both positive as well as negative integers. Then we have rational numbers, and we have also irrational numbers. Irrational means all those numbers which are not rational number. So what exactly are natural numbers? Numbers beginning with 1, going through 2, 3, 4, 5, 6, so on and so forth. These numbers are called natural numbers. And when we introduce a digit 0 with these natural number, then this set of numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, so on and so forth, this becomes whole number. So whole number is nothing but a set of natural number plus digit 0. And what about the integers? Integers can be called natural numbers with positive signs, natural number with negative signs. And what are positive integers? Positive integers means what are natural numbers? 1, 2, 3, 4, so on and so forth. When we place a positive sign before each number, say plus 1, plus 2, plus 3, plus 4, these become positive integers. Similarly, using a negative sign before these natural numbers, say minus 1, minus 2, minus 3, minus 4, so on and so forth, then these numbers are called negative integers. So integers are nothing but natural numbers with positive and negative signs. Now at this point of time, you might also be considering about digit 0, whether the digit 0 a positive integer or is it a negative integer. So you must keep in your mind that this number 0 is neither positive nor negative integer. So when we are talking about positive and negative integers, we are simply talking about plus 1, plus 2, plus 3, plus 4. And among the negative, minus 1, minus 2, minus 3, minus 4. We can also represent this integer in a number line. Number line means a scale where we have a 0, then we write number 1 on the right, followed by 2, 3, 4, 5, so on and so forth. Put the arrow over here. On the left side of 0 we write minus 1, minus 2, minus 3, minus 4, minus 5, and so on and so forth. So these number minus 1, minus 2, minus 3, these will be negative integers. All these number on the right side of 0 which have plus sign, which generally not written with this prefix plus, all these are positive integers. So this is how we represent positive and negative integer on a number line, and we exclude this digit 0 because it doesn't fall in the category of negative or the positive integer. I hope this much is clear to you. Now we'll move onward to the rational and the irrational numbers. What exactly are the rational numbers? In your mathematics books, you must have found that any number which can be written in the form of p divided by q or p upon q, where p in the numerator and q in the denominator are co-prime. What do you mean by co-prime? It means p and q doesn't have factors other than 1. Means p and q do not have common factor other than 1, means digit 1. Second, the number in the denominator is q, it should not be equal to 0. And why this condition here? This will be like if we have a number 3 in the numerator and 0 in the denominator, means q becomes 0, p becomes 3. In this case, the value of this number will be too high, which we write as infinity. Or should we also say it is not defined, because we exactly do not know how much big this number will be, and it is because of this reason this denominator should not be 0. Now coming back to this p and q being co-prime, a confusion might have crop up in your mind. What is this co-prime number? So without going further, I will give you a brief about this co-prime property. Suppose we have number 4 and 6. Here 4 has factor 2 into 2, 6 has a factor 2 into 3. So 4 and 6 has a common factor 2. What does it mean? It means this means 4 and 6 are not co-prime because they have factor 2 common to both of them, which is other than 1, means this one. And let us take another example of this co-prime. Suppose we have number 2 and 3. 2 has a factor 2 into 1, 3 has a factor 3 into 1. What is the common factor between 2 and 3? It is only 1. Therefore 2 and 3 are co-primes. It is this property which we have utilized in rational number, where numerator p and denominator q are co-primes and q is not equal to 0. Both these property needs to be fulfilled. So what do we have? So let us talk about this rational number. So any number which can be written in the form of p by q, where p and q are co-primes and q is not equal to 0, such number will be called as rational number. Say example, 1 in the numerator, 2 in the denominator, 3 in the numerator, 7 in the denominator, 5 in the numerator, 7 in the denominator, so on and so forth. So these numbers are rational numbers. 1 by 2 is a rational number, 3 by 7 is a rational number, 5 by 7 is a rational number. Now there are two more properties attached to this rational number. Suppose this rational number is written in the form of decimals. Say if we have a decimal 0.5, this point between 0 and 5, this is called decimal, and it is because of this decimal this whole number written as 0.5 is called a decimal number. I hope this is not a difficult concept to grasp. We can also take 1.5. Now take another number 1.3, 3, 3, 3. That means 3. This digit 3 keeps on repeating. Now you must see that we have number 1.5 and another number 1.3333, which is also written as 1.3 bar. This bar shows that this digit 3 repeats indefinitely. So in these two cases, in the first one, the digit 5 after decimal has no further number, so we say this number 5 after decimal terminates, so it will be a terminating decimal. And this one, the number 333 keeps on repeating, so it's a non-terminating decimal. But again you would see that this is a non-terminating decimal, but at the same time this number 3 keeps on repeating. So it's a non-terminating and recurring. Recurring means where the number keeps on repeating. So it's a non-terminating as well as recurring decimal. So any number which exhibit this property, a terminating decimal where a number after decimal terminates, or where a number doesn't terminate but one or more than two digits keeps on repeating. Here only digit 3 after decimal keeps on repeating, so it's a non-terminating as well as repeating decimal number. So both these properties also show that these two numbers are rational number. So we have three basic properties of rational number. One, any number which can be written in the form of p by q, where p and q are co-prime and q, the number in the denominator, is not equal to 0. Such numbers are called rational numbers. And 2, when number is written in the form of decimals, it must exhibit these two properties. 1, the number must be terminating. Second, if the number is not terminating, then the numbers should repeat, that is, the number should recur. So such numbers will be rational numbers. So in short, I must say 1 by 2, 3 by 7, these are rational numbers. Also 1.5 as well as 1.3 bar, all these are rational numbers. Similarly, what about this one? Say 4.232323. Will this be a rational number or not? Let us first look at this number. We have number 4 followed by a decimal, then 232323. We have two digits repeating after decimals, and thus these two digits are also non-terminating, means these 2323 keeps on repeating. So here 23 repeats or recurs after decimal. 223 repetition doesn't terminate. And we know when the number is not terminating but it is repeating, then such numbers will be classified as rational number. So in this case, this number 4.2323, which can also be written as 4.23 bar, this will be a rational number. And what about another example? Say 5.123 123 123. Again we have 123 digits repeating after one another, and this repetition doesn't end anywhere. So we have a repeating feature, that is recurring feature, as well as non-terminating feature. So we have a recurring feature, recurring of 1 2 3, and a non-terminating feature, means 1 2 3 1 2 3 keeps on repeating, doesn't ends anywhere. So both these property, when exhibited by any number, any decimal number, then such number will be classified as a rational number. Hope this much is clear to you. Now, after rational number, what we are left with is irrational number. What exactly is a irrational number? We can get an idea of this irrational number from the rational number itself. And here we will be making use of decimal features. Say a number which is written as 2.12356, and this and many more number keeps on repeating, but none of these number repeats. Means 1 2 3 5 6 doesn't repeat. We have other digits after 6. It may be 7 8 9 10 and 11, but none of the digits repeat, or sequence doesn't repeat. Sequence means like 1 2 3 1 2 3 1 2 3. Sequence doesn't repeat. So the digit doesn't repeat or the sequence doesn't repeat, but at the same time this number doesn't end anywhere. It doesn't stop anywhere, or should I say it doesn't terminate anywhere. So when any decimal number which exhibit the property of 1, where the number doesn't repeats and also doesn't terminate, then such numbers will be called as irrational numbers. So what is the property of an irrational number? Any decimal number where the numbers or the digits after decimal doesn't repeat as well as it doesn't terminate, then such number will be called as irrational numbers. We have examples of irrational number such as root 2, root 5, root 7, etc., etc. So I hope this video of few minutes might have been of some significance to your understanding. And if you have any comment, you can come back to me and we will collectively learn new topics and follow this real number subsequently. Thank you for watching and showing your great patience. Thank you.